And now, dear grade 10 students, we are going to talk about remarkable angles you've noticed at the beginning of this chapter and their families. The first remarkable angle we are going to talk about is 30. So these are the members of the family of 30. In quadrant 1 it is the angle 30 itself. In quadrant 2 it is 180 minus 30, or what we call by pi minus 30. So it is the supplement of 30 indeed, which is 150. In quadrant 3, the member of the family of 30 is 210. It comes from 180 plus 30, but 210 is not a principal value because it's not in the interval minus 180, 180. It's more than 180. Then we find its principal value using the previous methods, and it is minus 150. And in quadrant 4, the member of family of 30 is its opposite, minus 30. Here is a table referring to this circle, and this table includes the sine, the cosine, and the tangent of the angle and the member of its family. Sine of 30 is half, cosine of 30 is radical 3 over 2, and tangent of 30 is radical 3 over 3. We've proved that using the semi-equilateral triangle and so on. Now, according to 150, it is in quadrant 2. So 150 is in quadrant 2, and we have that all students take chemistry. This sentence makes things easier. So in quadrant 2, we notice that the sign is only positive. That's why sign of 150 is the same as sign of 30. Signs never change. So sine of 150 is equal to sine of 30, and you can make sure using the calculator, while cosine of 150 is the minus cosine of 30, because in quadrant 2 the cosine is negative, so we keep the value and we put a minus beside it, and obviously the tangent is going to be negative because it's by dividing sine by cosine. Now, minus 150 or 210 is in quadrant 3. Then the sine and the cosine are going to be negative, as you see here. So you take the sine of 30 and you put a minus beside it. Similarly for the cosine of 30 and you put a minus beside it. Then definitely the tangent is going to be positive because we are dividing negatives by each other. And finally in quadrant 4 there is the minus 30 degrees. Its sine is negative, its cosine is positive. So we take the same values and we change signs, okay? So minus for the sine, plus for the cosine, and minus for the tangent. Let's talk about another remarkable angle, which is the 60 degrees. The members of the family of the 60 degrees are in quadrant 1 itself. In quadrant 2, it's 180 minus 60, which is 120, the supplement of 60. In quadrant 3, it is 180 plus 60, which is 240, and whose principal value is minus 120. And in quadrant 4, it's the opposite, minus 60. And here is the table summarizing the ideas. Here is a trigonometric circle. Sine of 60 is radical 3 over 2, cosine of 60 is half, and tangent of 60 is radical 3. Now in quadrant 2, where sine is only positive, all again students take chemistry. So in quadrant 2, where only the sign is positive, you notice that we keep the same sign and the same value. Cosine is negative, as you see here, and the tangent is negative, so we keep the same value and we change the sign beside it. That's what I mean by a member of the family. They have the same value but signs are changed. Minus 120 is in quadrant 3 as well. In quadrant 3, all are negative but the tangent is positive, as you see here. Sine is negative, cosine is negative. And finally, minus 60 is in quadrant 4, where only the cosine is positive, as you see. The sine is negative and the tangent is negative as well. And now we are going to talk about a third remarkable angle, which is 45 degrees. In quadrant 1, it's 45. In quadrant 2, it's 135, the supplement of 45. In quadrant 3, it is 180 plus 45, which is 225, whose principal value is minus 135. And finally, in quadrant 4, it is the opposite, minus 45. And here we go. All students take chemistry. So in quadrant 1, 45, the sine and the cosine are both equal to radical 2 over 2. So the tangent is 1. 135 is in quadrant 2. And in quadrant 2, the sine is only positive and the others are negative, as you see. In quadrant 3, minus 135. So to remember, all students take chemistry. So in quadrant 3, the sine and the cosine are negatives, while the tangent is positive. And finally, in quadrant 4, the cosine is positive, the sine is negative, and the tangent is negative as well. And now, here is a training exercise to apply these ideas and to use some of the previous identities and rules we took before. Here is given sine alpha equals to radical 3 over 2, where alpha belongs to pi over 2 and pi. So alpha belongs to this interval bounded by pi over 2 pi, which is 90, 180. I have to determine cosine alpha, tangent alpha, and alpha. Solution. I have sine alpha and I want to determine cosine alpha. Think a little bit about the rule that joins sine and cosine together. It is the most famous trigonometric rule, which is sine squared alpha plus cosine squared alpha equals 1. Thus, cosine squared alpha equals 1 minus sine squared alpha. So 1 minus radical 3 over 2 squared, which is 3 over 4. And finally, cosine squared alpha is 1 over 4. So to find cosine alpha, I have to make the square root of cosine squared alpha, the square roots of 1 over 4. So cosine alpha is either plus half or minus half. Now I have to choose the exact true value for cosine alpha. Cosine alpha is either plus or minus half, but I go back to the condition. Alpha is in the second quadrant. How did I know that? Alpha belongs to pi over 2 pi, and as you know on the trigonometric circle, here where pi over 2 is, and here where pi is. So alpha is in the interval between pi over 2 and pi, so definitely alpha is in this region, which is called the second quadrant. Then in the second quadrant, only sine is positive, then definitely cosine is negative here, and thus I choose minus half for cosine alpha. So tangent alpha, by using the previous results, I divide the given sine alpha by cosine alpha, and the answer will be radical 3 over 2 by minus half, cancelling 2 together, I will get minus radical 3. Now how to choose alpha? I press on the calculator shift sine radical 3 over 2. So I press, let's write the steps, shift, then sine, then radical 3, as you see it here, you press it on the calculator, the symbol of the radical is found on the calculator, radical 3 divided by 2, and I put equal, the calculator will give me 60. So I know that this alpha is from the family of 60. So again, I use the given to press on the calculator shift, then sine, then the given value, okay, and equal. The calculator will definitely give 60. But it's not always 60. It may be another member of the family of 60. That's why I use the quadrant to choose the perfect exact value. So I know that alpha is from the family of 60, just I have to choose which one of the members of the family of 60 is the required answer. So in case I'm in quadrant 2, then definitely it is 120. To get 120 again, in quadrant 2, to get the member of the family of 60, I make 180 minus 60. So to get 120, I make 180 minus 60. This is how to get the member of the family of 60 in quadrant